This is a pre-lab video for our Fischer Thermo Scientific Model 42i chemiluminescent analyzer that we have here at the Red Deer College. It's used for measuring two pollutants, nitric oxide NO and nitrogen dioxide NO2. So you can see them being displayed on the front of the analyzer right now. First off, I just want to show how we pressure test the unit. We've got both of our gases that we'll be using over here. Right here is our nitric oxide, the NO, in the gray cylinder, and then in the red cylinder is nitrogen that we're going to be using to dilute our sample to create different concentrations. So right now both gauges, the downstream gauge and the upstream gauge, this main valve is shut, so these are both at 0 pressure. Same over there, so everything, and the regulator is backed all the way out. This valve also should be shut as well. Regulator backed out, valve shut, valve shut. So there should be no pressure in the lines. So what we're going to do is we're going to pressure test these two lines coming off. They flow down and they both flow into the rotometers right here. We got precision rotometers that we're going to be using for diluting our sample. And right now it's pretty rudimentary. We just have a cardboard box. We're waiting to get a cabinet built. If I take you around to the back side here, inside the box there's some hoses going, and the top of these 2 meters here, these 2 rotometers, the top of them, they tee together and then come out in one line here. So we go in at the bottom there, they come up the top, the calibration gas and the dilution gas, and then they mix and then come out the back here. So right now this is open. What I'm going to do is, I've got a fitting down here. I'm just going to steal a plug from that cross and thread it on and just kind of snug it up. I've got a wrench just sitting right here. We'll just kind of snug it up, and what we're going to do now is we're going to pressure test all the fittings just to make sure we don't have any leaks. So to do that, we're not going to use our calibration gas. We'll leave this turned off right now. We will use the nitrogen. And so what I'll do is I'm going to open the main valve here just a quarter turn roughly, and we should see pressure come up on our main gauge there. You can see it went up to 2000 psi, so I didn't have to open it much. Regulator's backed all the way out. We're going to open the downstream valve here of the regulator, and we're going to slowly increase this to about 5 psi on our gauge right there. So this might take a little bit to thread it all the way out. You should see it start to respond here. There, it's right about 5 psi, so we're probably good there. And now, both at the bottom of the rotometers here, I've got both these valves shut right now. You can see this line right here, which this is a Teflon line, this is just a poly plastic line, both rated for about 150 psi. This right here is the nitrogen, so it comes down and it goes over to this side right here. So I'm just going to open this, and we should see that ball rise up a little bit, the red ball right here. Some point, and I guess it didn't rise up, but it should be. I'm going to back both these all the way out. Oh, they're not, kind of rose up. So now we've pressurized all the tubing all the way up to the back there where we put that plug in the back of the box. It's all pressured up to about 5 psi. Maybe I'll just increase this a little bit more. It's a little bit below there, that's probably good. So now I'm going to shut this, and then what we would do is we would sit here and wait, probably wait for about 2 minutes or so, and then reopen this, and we want to also shut our main valve here as well. I'll just open this back up, sorry, we'll leave this open, shut the main valve, and now if there is any leaks in our system, what we should see over time is this gauge slowly starting to drop off. So you'd want to wait about 2 minutes to pressure test it, and if nothing happens after 2 minutes, then that means there's no leaks. So after 2 minutes you come back and you open this main valve here, and this pressure needle spikes up. That indicates that some pressure was lost somewhere. So we'll assume that it's pressure tested. We're good. I've already pressure tested this ahead of time. This is open. We're set at 5 psi, and now what we're going to do is we will shut both of these. Close them so there's no flow here. So now we will have no flow coming out of these lines from our cylinders. So since those are both shut now, we can go ahead and throw our calibration gas online here as well. So what I'll do is I'll open this main valve. We'll see the gauge spike up as well. Just open it a quarter turn. And we'll increase this until it got about 5 psi roughly. Pretty close, as long as we're got a little bit of pressure in there. And then now we can open this line here, and we are set and ready to go. So what we'll do is we'll go back to the back of the analyzer and connect it up for use. You can see right now we have this plugged. Since there's only about 5 psi in here, we can just slowly loosen this, and it's already bled off the pressure. No pressure there. And at the back of the analyzer, you're going to see 3 connections. We've got dry air coming into the analyzer. This analyzer requires some dry air. It requires oxygen for a reaction to occur. So you can see it's connected to this line right here, which is basically, this is just an air dryer. It's getting all the water out of the air, and then it flows in to the analyzer right there, into the dry air port. So we don't need to do anything with that. The other 2 lines though, this stainless steel one right here, it is, you can see it's labeled the exhaust. So the exhaust goes out on this braided hose, and then you can see it comes up and exits over here and goes out. It's one of our vent lines, so it's the exhaust for the analyzer. It gets vented outside. And then this Teflon line right here, this connects and goes down to this air filter that currently is just connected to nothing. So it's just, the analyzer's just drawing in ambient air. So there's a little pump in there that's sucking ambient air in. So what we want to do is we want to connect this up to our dilution station so we can start simulating a sample, or adding a sample to the analyzer. So to do that, we're going to use this chunk of tubing that's sitting right here, and we're just going to connect it, this end, to the outlet of our 2 rotometers. And one side of the cross here is going to go to the filter. We're going to put a cap on the other side of the cross, and then we need to take this cap off. You're going to hear the pump now, and connect this to the pump. So what we want to kind of do is just slightly snug these up now, and so they're good and snug. And so now what's happening here is, you can see we've got a bypass. So the sample is basically just circulating, because this here comes up to the cross, and then the sample can go down and back in, and then the exhaust is right here. It just keeps circulating through. When we start adding gas in here, what's going to happen is the pressure will start to rise a bit, and some will be going out the exhaust line, and some of it will be going to the analyzer. And that's how we're going to expose the gas to the analyzer. So I'll just take you around to the front here. And right now you can see our readings are still right around 0. So what we'll do is we'll use this side here. This is our calibration gas. And we'll just open this until we get some flow. That ball should rise up. So we got some flow. We'll put it up to, we need to have this, these are ranged. If you look at the chart here, this right here is our chart. At 150 on the rotometer, it's outputting 1093 milliliters per minute. So if we just rise, we can bring this up. We want to be maybe right around that 1000. It's about a liter per minute. We'll leave it right around there. And so now it's adding cal gas, and you can see the nitric oxide that's in our sample here is coming up. It should eventually stabilize somewhere around 50 ppm. So what I'll do now is what you're going to be doing in the lab is we're going to be diluting the gas. So I'm just going to lower this down to about halfway. We'll go down to about 80, I guess. So we're right around 80, and then we'll bring this up, our dilution gas, the nitrogen, we'll bring it up to 80. And what we should see happen here, if they're both at 80, we should see 50%. So that's right around 80. And this dropped off a little bit when we opened the other rotometer. We'll just bring him back up a little bit. Right around 80. A little bit of a self-balancing act here. We gotta balance these out. Right around 80, and right around 80. Ball should be, the mark here should be at the center of the ball. So if we back out here, and if we were to wait, it might take 20 seconds or so. The reading should be right around 25 ppm. And you can see it's coming down to about that right now, about 23 ppm. So that's what's in this bottle. Is if you look on the back side over here, it's a concentration of 50.1 ppm, and that is of nitric oxide, which is going to be NO. So now I need to shut this down just to show the proper procedure for shutting this down. So when we were all done with our readings, we're going to be doing a Rata test in this lab. What we would do is we would shut off the main valve here on both of our cylinders. Make sure it's good and shut, both of these, and what we should see happening is the pressure dropping off. So you can see the pressure's dropping here. Pressure's dropping here as well. And so we're going to basically bleed off all the pressure through our analyzer until we can maybe actually open these up so it's a little faster. You can kind of hear the regulators now bleeding off faster. I'll just and there you can see both main gauges are down and everything's at 0 and 0. So now we can back our regulators all the way out. So back this guy out, and then shut this valve here as well. So shut both these. Shut this, turn this all the way out, counterclockwise, and then clockwise on both the valves. And then everything should be shut in. And you can see these are at 0 flow. We've taken all the gas out of the lines. Alright, and now we're just going to go back around to the back side here and just quickly disconnect all of this stuff that we had connected. We'll just pull this line off here. Take this off right here. And then put our cap back on. And we can basically take this off. I don't have the wrench handy. I'm using my other hand to hold the phone, but loosen this connection and then just have our filter back open to atmosphere again. And that is everything.